All right, here we go. This is the section 5.1 pre-calculus instructional YouTube video. So simplifying trig expressions, like using algebra and trig identities, and then doing a little factoring with some trig functions in the expressions. So first, let's talk about some of our identities that we have. So we have the reciprocal identities. Reciprocal. Right, these are just the ones that tell us like sine of x is 1 over cosecant x, and cosecant x is 1 over sine x. These are ones that you should know. Cosine x is 1 over secant x, and secant x equals 1 over cosine x. And then tangent x, 1 over cotangent x. Cotangent x is 1 over tangent x. Right, you should know those. Boom, those are reciprocal identities. We have what are called the quotient identities, where tangent of x is sine x over cosine x. Cotangent x equals cosine x over sine x. Because remember, right, tan and cotan are reciprocals, so they're the flip of each other. All right, lastly, we have our Pythagorean identities. The first one is sine squared x plus cosine squared x equals 1. And to get the other two, what I can do is I can just either divide this all by sine squared or divide it all by cosine squared x. So if I divide each of these by sine squared x, I get 1. Sine squared over sine squared is 1. Plus cosine over sine is cotangent, so cotangent squared x equals 1 over sine, which is going to be cosecant. Cosecant squared x. If I divide each of these terms by cosine squared, I'm going to get sine squared over cosine squared, which is tangent squared, plus cosine over cosine, or cosine squared over cosine squared, 1 equals 1 over cosine squared, which is secant squared x. Those are the identities that you need to know. We talked a little bit about how we get this one in class. If you want to get into where these come from, we can do that at another time. Our goal today is to apply these identities and simplify using them. So, normally, not in this video, but we'd learn the even odd functions, right? Even functions are cosine of negative x equals cosine x, right? And then secant the same way. And then odd are the other ones. So sine of negative x equals negative sine x. And then we also have the cofunction identities, which is basically saying if you have a function and a cofunction, like sine and cosine, secant and cosecant, tangent and cotangent, right? Function, cofunction. They all follow the same pattern where sine of pi over 2 minus the angle is equal to the cofunction of the angle. And vice versa. If I go cosine of pi over 2 minus x, right, that's sine of x. And once again, we can talk about why that works another time. All right, but this works if I change sine and cosine with secant, cosecant, with tangent, cotangent. Same thing holds true. So now remember, with all of these identities, what this allows us to do is to replace or substitute in an expression to make it more simple. So for example, if I have a tangent x in an expression, I could replace it with sine of x over cosine of x, or I could replace it with 1 over cotangent x, right? Because they are equivalent. Now that might seem like it's making it more complicated, but if I replace it with a sine over cosine, maybe things will cancel out and it'll get more simple, right? It just depends on what the problem is. Right, if I have a cosecant squared x, I could replace it with a 1 plus cotangent squared. If I have, let's say, a sine squared x somewhere in the problem, I could subtract cosine squared on each side here, and I could replace sine squared x with 1 minus cosine squared x. Right, we can use these, and we can do algebra on these in order to replace or substitute in an expression in order to simplify it. So let's go ahead and do an example where we're going to simplify, and that's what the rest of this video is going to be. It's just going to be simplifying expressions. So let's say we have sine x, cotangent x, secant x. I want to simplify this. So we look at this, we're like, all right, we've got a sine here, wonderful. Now cotangent and secant, we can rewrite those in terms of sine and cosine using our reciprocal and our quotient identities. So what I'm going to do is I'm going to take this sine x and I'm going to keep it as sine x. And then I'm saying we're multiplying by cotangent x. Cotangent is cosine x over sine x. It's the reciprocal of tangent. Right, we got that here. And then secant is 1 over cosine. So multiply by 1 over cosine x. And I can make this sine x over 1 so that it looks nicer. And now I can look at it and go, okay, well, I have a sine x in the multiply and a sine x in the divide by spot of our fraction, our rational expression. So those are going to cancel out. I have cosine x in the numerator, cosine x in the denominator. Those are going to cancel out. And we're just left with 1. And that's the answer. It just simplifies down to 1. Right, and the important thing here to identify is how we rewrote the cotangent in terms of sine and cosine, rewrote the secant in terms of cosine. So basically, we can rewrite everything in terms of sine and cosine. Sometimes that's a strategy that'll work to get us where we want to go. All right, let's look at, what if we have tangent theta minus tangent theta cosecant squared theta. All right, looking at this, if I want to simplify here, I notice I have two terms, term 1, term 2, and each one has a tangent theta in it. So what I'm going to do is I'm going to factor out that tangent theta by dividing it out. So I get tangent theta times tan theta divided by tan theta would give me 1, and then minus, divide out this, so I just get cosecant squared theta. So tangent theta times 1 minus cosecant squared theta. Well, what I want now is I notice, hey, I got a cosecant squared. If I have a cosecant squared, that tells me I probably want to use one of my Pythagorean identities. And I know cosecant squared is equal to 1 plus cotangent squared. So I'm going to substitute, instead of that cosecant squared, we're going to use the Pythag. We're going to use the Pythagorean identity, and we're going to replace it with what it's equal to. So it's going to be 1 minus. And don't forget your parentheses here. We're subtracting a cosecant squared, so we need to subtract the whole thing that it's equal to. So 1 minus, and then 1 plus cotangent squared theta. Now I'm going to distribute the subtraction in order to simplify. So I have my tangent theta times 1 minus cotangent squared theta. 1 minus 1, hey, that's 0, that cancels out. Woohoo! So now I just have tangent theta times negative cotangent squared theta. Right, well, what can we do here? Well, I have a cotangent squared and I have a tangent. What's the relationship between tangent and cotangent? They are reciprocals of each other. So I could either rewrite cotangent as 1 over tangent, or I could rewrite tangent as 1 over cotangent. Because I have my cotangent squared, I'm going to rewrite the tangent so that I end up with my answer being in the numerator. So I'm going to take this tangent and I'm going to rewrite it as 1 over cotangent theta, and then times negative cotangent squared theta. Right? I have I have 2 cotangents multiplied in the numerator. I have 1 multiplied in the denominator. I'm going to cancel 1 out. And that's just going to give me negative cotangent theta as my answer. And boom, that's it. Cool. All right. So I've got one more example of that, and then we're going to do a couple factor examples, and that is it for the video. So this next example is a little bit more complicated, but that's a good thing. All right. So this next example is we want to simplify sine of t plus cotangent t cosine t. So we want to simplify that. Excuse me. So a good idea, the first thing to do is to see if we can rewrite this cotangent in terms of sines and cosines, and see kind of if we can get towards simplifying in that direction. So cotangent, remember, is cosine over sine. So I'm going to rewrite this as cosine over sine. So we have a cosine t over sine t, and then we have a cosine t still there, which looks like cost. Let's put a little parentheses around these. There we go. That's better. The book doesn't use parentheses, but I mean, that way we don't have like multiplying costs together. Well, looking at this, now I have a fraction, right? And I have an addition problem. This one has a fraction in it. So what we want to do is I want to make this have the same denominator as that. So in order to have a common denominator, well, the denominator in this expression, right, this part, this term, has a sign in the bottom, so I need a sign in the bottom here. So I'm going to multiply by sine of t over sine of t on this sine of t term, which is going to give me sine squared t over sine t plus cosine times cosine gives me cosine squared t over sine t. Common denominator, I can add the numerators now. So I have sine squared of t plus cosine squared of t over sine of t. Woo. We're like, hey, do you recognize this? Sine squared plus cosine squared? I hope so, because it's Pythagorean identity. It's just equal to 1. I can replace this sine squared plus cosine squared with a 1 and just get 1 over sine of t. But since that's a fraction, since it's a rational expression, right, it's not as simple as it can be. 1 over sine, that's cosecant. So we're just going to write it as our answer, cosecant of t. And that's it. That's the answer. All right, now we're going to move to factoring. So first, we're going to factor 6 sine squared x minus sine of x minus 15. Okay, this might look a little bit weird. Probably does. What we do here is say, hey, it's a sine squared and a sine. We can do a little substitution and we can replace sine of x with just some random letter. It could be A, it could be U, it could be whatever. Just make sure it's not that letter, right? We're just gonna put a placeholder in for it so it's not as confusing to look at. And this isn't something that you have to do, it just makes the problem a little bit, it makes the problem seem more manageable. It's still the exact same problem though. So what I'm gonna do is I'm gonna go, what about this problem? 6a squared minus a minus 15. Can I factor that? Right, I'm just replacing the sine of x with an a. Well, if I draw my rectangle, or my area diagram, all right, 6a squared goes here, negative 15 goes there. I need two numbers that add to negative 1 and multiply to whatever 6 times 15 is. Well, 60 and 5 and 9. 90, right? Negative 90. So I need two numbers that multiply to negative 90 and add to negative 1. Hey, how about negative 10 and 9? Right, so it gives me negative 10a, 9a. Well, so I need to break this down. 3a times 2a gives me 6a squared. 3a times 3 would give me 9a. 2a times a negative 5 would give me negative 10a. And hey, look at that, that multiplies to negative 15. So I have 3a minus 5 times 2a plus 3. But that's not our answer. Why? Because our problem didn't have any a's originally. It had sine of x. So I got to go back here and redo that substitution. Instead of an a, I'm going to put in sine x. So I have 3 sine x minus 5 times 2 sine x plus 3. And that is my final answer there. All right, one more problem, and then that's it for the video. All right, we are going to factor cosecant squared x minus cotangent x minus 3. So this one is trickier because we have a cosecant squared and we have a cotangent regular. They're different trig functions. So I could, if I wanted to do a substitution, I'd have to choose different variables, and I'd have something like a squared minus b minus 3. We can't factor that. We gotta have these need to be the same thing. So, like, hey, I got a cosecant squared, maybe, boop, I have a Pythagorean identity that relates cosecant squared with cotangent squared, and we do, right? Cosecant squared is equal to 1 plus cotangent squared. So what I'm going to do is I'm going to replace this cosecant squared. We're going to do a little Pythag action. And we're going to replace it with a 1 plus cotangent squared x using this identity. These are the same thing. Cosecant squared is the same as 1 plus cotangent squared. So I can replace or substitute in any expression I want. And I want to do that so that I get cotangent squared and cotangent together. All right, so I have 1 plus cotangent squared minus cotangent, or sorry, cotangent squared x minus cotangent x minus 3. I'm going to combine the 1 and the negative 3. So I have cotangent squared x minus cotangent x minus 2, and I'm going to factor this. Well, I can do the quick substitution. Oh my goodness. I'm going to go cotangent x, I'm going to replace it with an a. So I have a squared minus a minus 2. Say, well, I need two numbers that multiply to negative 2 and add negative 1. So let's go like a minus 2, a plus 1. Right, multiplies to negative 2. I'd get a negative 2a, positive a. It's negative 1a, a squared. There we go. And then just replace the a with a cotangent x. So I have cotangent x minus 2 times cotangent x plus 1. Okay, and those are the examples for this video. The big idea here is to look at the problem and identify which of these do you need to use. And it might take, 10, 15, 20, 30 minutes over the next week or so of just like working with these and looking at them, just like looking at them, reciting them in your head, maybe just 10 minutes, and getting to know them so that you don't have to keep looking back at your notes form. That will help if you actually do that. And remember, with these Pythagorean identities, you can always build the other ones as long as you remember the sine squared plus cosine squared equals 1. Just either divide by sine squared or divide everything by cosine squared to get the others. But, right, if you can use your notes, you can just use your notes. So, thanks for watching. Remember, I got office hours if you got questions, and have a wonderful day.